So good morning, students. In the last class, we had discussed about the revision. Before that one, we were talking about the microbes in human welfare. In that, we had studied about the microbes in the household products, microbes in industrial products. During industrial products, we had discussed about the antibiotics. Okay, what is that antibiotic which we had discussed? Means that is the penicillin. Penicillin, which is one of the first antibiotic which was discovered, means that is the penicillin. Who had discovered that penicillin? Means that is the Alexander Fleming. While he was working on the bacteria, that is the Staphylococcus bacteria. Okay. On that, while he was working with the Staphylococci bacteria, which is one of the infectious bacteria to cause the whatever the pneumonia. So during that time, he found some of the mold of fungi and he searched on that one. Then he found that particular mold, it is one of the fungi. And what is that fungi? Means that is the Penicillium notatum. And that Penicillium notatum, that is going to secrete some of the chemical substance, and they named that as the antibiotic. And two more scientists were involved in that one. That is their names are Ernst Chain and Howard Florey. They both also again they worked on the same antibiotic, that is the penicillin. Then they whatever during the Second World War in the 1945, the soldiers who was wounded, so that penicillin was treated to that soldier. So this is about the story of what penicillin. So next we will go for the some other industrial products in which the microbes are used. What are that means? Such as chemicals, enzymes and other bioactive molecules. Microbes used in the production of chemicals, enzymes, okay, chemicals, enzymes and other bioactive molecules. Other bioactive molecules. So, whatever the things are, let's see what are the microbes which are used in the production of some of the industrial products. And what are the industrial products? Here, these all are the industrial products. So, in that class, we have studied only about the antibiotics. And one more thing, keep in mind that whatever the industrial products which are going to produced in a very large scale or in a very large quantity, they are going to use the large tank bioreactors or that bioreactors which is also known as the fermenters. Okay, in this large stainless steel vessels, they are going to produce all these things, or they are going to synthesize all these industrial products. So, chemicals are there, enzymes are there, certain enzymes are there, and certain bioactive molecules are there. So, let's see what are that particular chemicals over here. See here, which microbes they are going to use means most common microbes which are used over here means that is bacteria and fungi. Which microbes are used here in the industrial product means that is mostly bacteria and fungi which are used commercially for the industrial production of enzymes, acids or whatever the chemicals what we are calling or organic acids, alcohols and vitamins. So bacteria and fungi are used majorly in what industrial products. So some of the first we will see about the acid. Okay, some of the organic acids. Here they had given the chemicals. In these chemicals, organic acids will also come. These organic acids, some of the organisms or microbes are responsible for the production of what? Some of the acids, such as some of the to that microorganism you can call it as the acid producers, such as Aspergillus niger. Aspergillus niger. Here, the Aspergillus niger, it is one of the fungi. Okay, it is one of the species of what? Fungi, which is going to produce one of the organic acid, which is that acid mix that is going to produce the citric acid. Which acid? That is the citric acid. The next Acetobacter aceti. Second one, which is one of the bacteria. Acetobacter aceti, which is one of the bacteria. Here, this Acetobacter aceti, it is going to produce an acid. That acid name is acetic acid. What it is? Acetic acid. Commonly you call it as the vinegar. Okay. The next, Clostridium botulism. This is also one of the bacteria. Clostridium botulism. This is also one of the bacteria which is going to produce an acid, that is the butyric acid. One of the most common bacteria which you had already studied during the microbes used in the household product. What is that we mix? Lactobacillus. Lactobacillus. This is also one of the bacteria which is used in the production of an acid. That acid name is the lactic acid. So these are some of the acids which are produced by using the microbes. Aspergillus niger, which is one of the fungi used in the production of acid, that is the citric acid. Next, Acetobacter aceti, which is also one of the bacteria used in the production of acetic acid or vinegar, which is commonly called. The next, Clostridium botulism, which is also one of the bacteria used in the production of butyric acid, and all these acids are the organic acids. Next, we will show whatever these acids are going to produce, that will be produced in a very large quantity, in which tanks they are going to produce mix, that is the bioreactors or fermenters. Next, we will see about some of the enzymes. See here, we have talked about the chemicals. Next, we will see about the enzymes. So see here. Next one, that is about the enzymes. We will see here. See, one of the alcohol or acid is produced, not acid, which is one of the alcohol. Name of that alcohol is ethyl alcohol, which is produced at a commercial scale. What it is? Ethyl alcohol, which is produced at a very large quantity or a commercial scale, that is in the bioreactor, and this production is catalyzed by an enzyme. Is catalyzed by an enzyme. The name of that enzyme is zymase. What is the name of that enzyme? That is the zymase. Here, the zymase, which is one of the enzyme which is used in the production of what? Ethyl alcohol in a very large quantity. So here, which microbes are going to use here? Means for the production of this enzyme cyclase, means that is the yeast cells. For the production of cyclase, which is one of the enzymes used in or catalyzes the production of ethyl alcohol, and here the cyclase is produced by an yeast cells. Yeast cell means that is the fungi. Then here yeast cells or yeast, fungi and other microbes are also used here for the production of enzymes. And what are that enzymes means? Such as proteases, alpha amylase, pectinase. Here, these are some of the names of enzymes which are obtained by what? By the microbes. Invertase, catalase, then protease, alpha amylase, pectinase, invertase, catalase, maltase. So all these are obtained from where? These all are obtained from or produced from microbes. Which are that microbes over here? That is the either it may be fungi or bacteria. So let's see specifically which enzyme is produced by or obtained by which microbe. First, that is maltase and alpha amylase. Maltase and alpha amylase, which are the two enzymes. Specifically, these two are obtained from the two species of fungi. Which are the two species of fungi? Means that is mucor and rhizopus. These are the two species of fungi. Mucor and rhizopus. These are the fungi or the microbes which are going to produce the maltase and alpha amylase. The next, pectinase, protease and catalase. Three enzymes: pectinase, protease and one more enzyme is there, that is the catalase. These three of the enzymes are obtained from a fungi that is known as the Aspergillus niger. This is also one of the fungi, Aspergillus niger, which is used in the production of enzymes such as pectinase, protease and catalase. The next, invertase is obtained from yeast. Invertase obtained from what? From the yeast, which is also one of the fungi. So here this is about certain enzymes. Next comes the other bioactive molecules. So let's see about that bioactive molecules. Here, in that bioactive molecules, streptokinase is there, one of the bioactive molecule. The name of that one is streptokinase. See, streptokinase, which is also one of the enzyme, okay, which is produced by a bacteria, that is the streptococcus. What it is? Streptokinase. Streptokinase, which is produced by a bacteria. The name of that bacteria is Streptococcus. Okay. Here, streptokinase or streptococcus bacteria, first of all, it is that bacteria is going to produce an enzyme streptokinase. That streptokinase is modified. This enzyme is modified by a technique that is known as the genetic engineering. Modified by genetic engineering. When they modified by using this method, that is the genetic engineering. So here this streptokinase is used as a clot buster. See, many times they had asked for 1 mark question. Okay, what is the use of streptokinase? This is very important point. Okay, why it is using as a clot buster? What do you mean by clot buster? Here, clot buster means which removes the clots from the blood. Okay, clot buster means which removes the clots from blood. That's why here this enzyme streptokinase, it acts as a clot buster. How means it removes the what? Clots. Clots means sometimes the blood cells are going to aggregate and it will form a coagulation. That is the clot. That clot is, if there is a presence of clots in the blood, there may be a chance of heart attack. That clot busters are going to removed by this what? That is the streptokinase. So, for removing the clot buster from the blood vessels of the patient, which is undergone myocardial infarction. Myocardial infarction. That means this is one of the what we call, this is one of the heart attack. What we call myocardial infarction, which leads to this myocardial infarction, which leads to heart attack in the patient. So, who is going to prevent the clots from the blood vessels? Whatever in the blood vessels. See, for example, this is the blood vessel and this is the flow of blood. Sometimes there will be presence of certain clots. Okay, who is going to remove these clots? Here, that is the streptokinase. So, how the question will be asked is, why the streptokinase is known as the clot buster? Okay, otherwise they will ask what is the function of the streptokinase. In this sense they will ask, so this will be for 1 mark. The next here, and streptokinase, it is also known as the tissue plasminogen activator, that is the TPA. Okay, what is TPA? Tissue plasminogen activator. Okay, the next, so some other yeast and fungi are also the sources of a riboflavin. Here comes one more bioactive molecule, that is a vitamin B2, that is also known as the riboflavin. Let's see about that one. So please note it down. Here, see, yeast and other fungi, they are also the sources of. Here next comes the bioactive molecules. Among that bioactive molecule, one molecule is there, that is the vitamin B2, or which is also known as the riboflavin. So this vitamin B2 or riboflavin, which is produced by some of the yeast and fungi. Yeast and fungi. So one more bioactive molecule is there. This is also very important. That is the D-statins. What it is? D-statins. Mark it for 1 mark. D-statins. Here, these D-statins are produced by the yeast. And what is the species of that yeast means? That is Monascus purpurus. Monascus purpurus. This is the name of yeast which is going to produce these statins. Next, what is the role, what is the function of this bioactive molecule means? Here, this is also very important. It is used as a blood cholesterol lowering agent. This statin, it is used as a blood cholesterol lowering agent. So what it is using? For lowering the cholesterol level in the blood by acting as a, how means, it will act as a competitive inhibitor by acting as a competitive inhibitor. Inhibitor for what? Inhibit means which will slow down the reaction. Inhibitor of enzyme of cholesterol synthesis. Here, the statin, which is one of the bioactive molecule, which is produced by the yeast, that is the Monascus purpurus. Sometimes they will ask by which microbe it is obtained. In that case, you have to mention that name. Okay. Otherwise, they will ask what is the function of these statins. Okay. Here, first of all, it is used as a blood cholesterol lowering agent. That means, for example, this is the blood vessel. Okay, in this blood vessel, the cholesterol means which will be a fat. Okay, that cholesterol are going to deposit. If like that, only the cholesterol level is going to increase, which may block the blood vessel. Okay, if blood vessel. If these are the cholesterol, the blood flow or the blood pressure is going to lower. Okay, cholesterol level increasing. At that time, the blood pressure is going to low because the pressure is going to decrease due to the presence of what? Cholesterol in the blood vessels. So what happens is these statins are going to lower, or these statins are going to diminish or reduce the level of what? Cholesterol. What is that? That is the these statins. So how they are going to reducing, how they are going to decline this what we call cholesterol? So what they will do is they will act as an competitive inhibitor. See, whatever the enzymes here, the enzymes which is catalyzing the reaction of cholesterol synthesis, means which are making the cholesterol in the blood, so that enzymes will be there. Some enzymes will be there for the production of cholesterol in the blood. So here these statins will inhibit this one. Inhibit means they will stop them to catalyze this reaction. They are going to stop the reaction or the formation of what? Cholesterol into the blood. In that sense, we are saying it will act as a competitive inhibitor of enzyme cholesterol synthesis. Okay, that's why we are calling it as the blood cholesterol lowering agent. Then one more biochemical agent is there, that is the cyclosporine A, that we will see. Here you see. Next biochemical molecule, that is the cyclosporine. Okay, the cyclosporine A, this is an important bioactive chemical produced by the fungus. It is produced by a fungus. And what is the name of that fungus? The name of that fungus is Trichoderma polysporum. Trichoderma polysporum. This is also very important for 1 mark. Okay, which microbe is used in the production of a bioactive molecule? That is the cyclosporine. It means what is Trichoderma polysporum, which is one of the fungus. Here, what is the function of this means? This is used as an, this cyclosporine A is used as an immunosuppressive agent. Suppressive agent. Okay, so this immunosuppressive agent in what? In organ transplant patients. See here, this is the person 1. Okay, and this is the person 2. Okay, this person has a kidney failure. One kidney is got failed. In what? In the person 2. So this person 1 wants to give his kidney to the another person. Okay, so he is donating his kidney to to that next person. But the immune system of that number 2 person should accept that kidney. Then only this person can donate to that person. Okay. So if not, if immune system is not accepting that one reserve, that transplantation is failed. Okay. They have to search for some other donor. Okay. So here, what happens is, for that organ transplantation, they will give this chemical, that is bioactive molecule, that is the cyclosporine A. They will inject them with this, so that their immune system, immunosuppressive means their immune system should accept that kidney. Okay, they should not reject. So that agent, they had given the name of that agent, that is the immunosuppressive agent. Who is using, which bioactive molecule is used as an immunosuppressive agent, is that is the cyclosporine A, which is obtained by fungus, that is the Trichoderma polysporum. So this is about what? About the microbes used in the production of chemicals, enzymes and bioactive molecules. So next we will go for the next topic, that is microbes in sewage treatment. This is also very important. You note it down. This which microbe is used, except that one. What is the uses? What is the function of this cyclosporine A? Okay. This is all about the industrial products. Next see this one, that is, next topic is microbes in sewage treatment. This sewage treatment question will be asked for 5 marks. So first we will see, we will understand the meaning of sewage. What is sewage? Okay. What is sewage? Means it is a municipal wastewater. It is a municipal wastewater containing domestic waterborne waste, domestic waterborne waste, including human and animal excreta, washing waters, these are nitrates, phosphates, the next biodegradable organic matter, and many types of pathogenic microbes. Many types of pathogenic microbes. So, this is the meaning of sewage. As you know, whatever the drainage system or the ponds, lakes, rivers will be there, whatever the industries, houses will be there, they are going to release their waste into these water bodies. These water bodies now becomes a municipal wastewater. What it will become? It will become a municipal wastewater. See, if there are some factories, they will release some of the harmful chemicals, such as the dissolved nitrates are there, phosphates are there, and if animals are there, humans will be there in this, they will excrete their fecal matter into the water bodies. So municipal wastewater means in the houses, for example, these are the houses. So in the houses, whatever the washing waters, whatever they are going to use for domesticated wastewater, what we call, that water is also going to added over here. That means all the dirt water, the waste water, whatever flowing in the drainage system, so that we can call it as the sewage. What it is? It is a municipal wastewater, any domestic waterborne waste, including human and animal excreta, washing waters, dissolved nitrates, phosphates, biodegradable organic matter, and many types of pathogenic microbes. And one more thing, in this water, there will be presence of many number of pathogens. So now this water has become a very unfit for the food, cooking the food, or unfit for the drinking. That means the sewage water is untreated water. It is not fit for the drinking purpose or consumption of for the human beings. Okay, so what we can do for this water means they are chemically, this water, sewage water, if we see chemically, the sewage water will have a 99% of liquid and 1% of solid waste. 99% it will be a liquid waste, only 1% such as what we call stones, pebbles, sand, grit will be there, 1% it will be there in the water. So, and also it will include all the organic matters as well as the inorganic matters. So, the sewage also has the microbes, both pathogenic and as well as non-pathogenic. So, this cannot be discharged into the natural water bodies. Natural water bodies, what I told just now, such as rivers are there, ponds are there, lakes are there, these are the water bodies. So that drainage system, whatever here I am showing, this drainage system should not release into these water bodies. So that the animals, the plants, the human beings, all the living organisms are getting the water from these water bodies. If they are consuming like that only untreated sewage water, there may be many number of pathogenic microbes, unpathogenic microbes will be there. Some may cause severe diseases. So before discharge, the sewage has to be treated. The sewage water has to be treated, or before discharging. See how they can treat. So here one factory is there. That is the BOD. What is that? What is the meaning of that BOD? You can see here. See, in this water, whatever here we are seeing in this water, I will represent it with the red color. This is the sewage water. Okay, in this all the waste is there. So here what happens if it is discharged like that only in this water bodies? What happens means the normal amount of dissolved oxygen in this water or whatever the sewage water is there, the normal amount of dissolved oxygen, see, always you keep in mind in water, see, H2O, okay, 2 hydrogen and 1 oxygen. So this oxygen, it will be not free oxygen. Okay, this is not a free oxygen. This oxygen is a dissolved oxygen. What it will be? It will be a dissolved. Always in water, whatever the oxygen atoms will be present, it will be a dissolved oxygen atom. So here, what happens means whatever the dissolved oxygen present in water, sewage water, it gets quickly utilized by the microbes. Dissolved oxygen means it gets quickly utilized by the microbes. See here, in this water, whatever the dissolved oxygen is there, for example, this is the oxygen. It is, if it is present in the sea, whatever the oxygen, dissolved oxygen which is present in the sewage water, it's get quickly. Who is going to consume that oxygen? That is the microbes. These microbes, it may be the harmful one or it may be the non-harmful or beneficial one, so that they will get it, utilize it in the sewage water. And what happens is at that time, they are going to take all that oxygen from the sewage water. At that time, the BOD, it is going to increase. What is the full form of BOD? Means that is the biochemical oxygen demand. What is biochemical oxygen demand? See, in this sewage water, oxygen is almost utilized by whom? By the microorganism. So, this is the oxygen which is utilized by the microorganisms. These microorganisms are going to utilize that oxygen from the sewage water. So, what happens is here the demand for oxygen in the sewage water. See, if oxygen is not there in the water, means the demand means the water requires the more oxygen. So that is the biochemical oxygen demand in the sewage water is going to increase. If the BOD is increased, oxygen demand is increased, then that water is highly polluted. What it is? That water is highly polluted. When it takes place means when it gets highly polluted means when sewage water is discharged directly without treating, it will get discharged directly into the water bodies. At that time, the BOD is going to increase. The oxygen demand is going to increase. If it is treated, then they are going to discharge there. So the BOD will be decreased. If the BOD is decreased, means the water is less polluted. Now this water is fit for drinking. Why? Because there is a presence of what? Oxygen in the water. The demand is decreased. Then now water is fit for drinking, or which is less polluted, or which will be a normal water for the consumption. So the next in the next class I will explain there are three steps or three types of treatments. Three steps in the treatment of what? Sewage water. That I will explain in the tomorrow's class or in the next class. Okay, thank you.